Welcome to True Projects. In this video, we are going to explain about the project that is Analytical Validation and Integration of CIC Bell DNS EXF 2021 dataset on security information and event management. So before getting into the execution, first let us understand what is the project about. Think about how we rely on internet every day, whether it is browsing websites, sending emails or using any other apps. All of these actions depend on something called DNS, which is like an address book for the internet. So when you type in a website name, DNS translates that into an IP address so your computer can find the site. Now imagine if someone found a way to steal the information into those DNS requests and responses. It is kind of like hiding a secret message inside an ordinary letter. This is exactly what happens in the DNS exfiltration attacks. So in these attacks, cyber criminals they take the advantage of the fact that DNS is often overlooked when it comes to the security. They hide sensitive data in the DNS queries or responses that makes it look like a normal internet traffic. So when these are being done, it just looks like a normal internet traffic. Since DNS traffic is huge, most of them they look like legitimate, that is genuine. It is hard to spot the malicious activity. So by using these methods, that is attackers, they steal the data. They steal the data, they set up ways to control a compromised system. They launch denial of service attacks. They launch the denial of service attacks to overwhelm the services and also even they distribute the malware. The real challenge for cybersecurity professionals is detecting these kinds of attacks because malicious data is buried in the middle of all regular DNS traffic. We do have some traditional security systems like firewalls or SEIM, that is nothing but security information and event management systems. They are great at protecting against a lot of common cyber threats. But when it comes to the advanced attacks like those that hide DNS traffic, these systems they can struggle. This because they don't always have the right tools to detect these kinds of sneaky methods like threat intelligence, which helps to identify emergence attacks. So these they help in emergence attacks. And coming to the next one, that is behavioral analysis. So this which looks for unusual patterns in the behavior or anomaly detection. When it comes to the anomaly detection, this spots things that don't quite fit the normal activity. Traditional security methods might miss the hidden door because it doesn't know how to look for it. DNS based attacks are like that hidden door. If they go undetected, attackers can silently steal the information, disrupt operations, and they can also cause the financial losses. It is very huge, right? So to really address this kind of threat, we need better detection methods that go beyond basic security. These methods need to specifically monitor and also analyze DNS traffic in real time to catch malicious activities before they cause the harm. It is all about improving how we monitor and also protect the DNS traffic to stop these attacks before they can do any damage. Let me tell you some more points about DNS. DNS traffic is the data exchange between devices and the DNS servers, which translates domain names into IP addresses. So when you enter a URL, your device sends a query to the DNS server to find the corresponding IP address. So this process allows you to connect to the websites. However, DNS traffic is typically trusted since it's normal part of how the internet functions. Attackers can exploit this trust by hiding the malicious data within DNS queries and also responses. This leads to DNS exfiltration. So this leads to DNS exfiltration. We call it as DNS exfiltration. Attackers exploit this trust by hiding malicious data. So in these attacks, sensitive information is secretly extracted from the organizations through DNS traffic by passing traditional security measures. So to detect these hidden threats, we are proposing hybrid intrusion detection system that analyzes DNS traffic patterns using powerful machine learning algorithms. So in this project, we are using decision making methods that are, so here we are using random forest with AHP, KNN, TOPSIS, GVT, VIKOR, and DT entropy TOPSIS to detect abnormal behavior and identify DNS exfiltration attempts more accurately. So we evaluate its effectiveness using metrics called accuracy, precision, recall, kappa value, and RMSD. The machine automated function streamlines the integrated and validation of various models, ensuring the key work seamlessly together. This system excels at detecting DNS exfiltration attacks and performs better than previous methods in classifying multiple types of attacks. It demonstrates improved accuracy and also reliability, making it more effective approach for identifying and categorizing these threats. Moving on to the extension part to further improve the accuracy. In this project, we are incorporating voting classifier. This method combines the predictions from several different models to make a final decision. Think of it like getting input from multiple experts to make a better informed choice. By using this approach, we can take the advantage of strengths of each individual model, which makes the overall prediction more accurate and also reliable. On top of that, we have built a user-friendly front-end interface using Flash framework. This allows users to interact with the system more easily, which provides a smoother experience to the users. And we also have included user authentication mechanism, ensuring that only authorized individuals can access the system, which helps keeping everything secure and protected. This extension not only makes the system more accessible, but also ensures it's safe and easy to use. Coming to the implementation, to implement this project, we have followed the steps in the flow of work. So coming to the first step, we import packages. First, we import the necessary libraries and packages that are required to handle the data processing, modeling, and visualization. Coming to the next step, exploring the dataset. Here we load and explore CIC Bell DNS EXF 2021 dataset, which contains the information on DNS exfiltration attacks. This helps us to understand the structure, features, and also types of the data we are working with. The next step is data processing. Here we clean the data. It includes removing duplicate values. That means we remove any duplicate entries to avoid bias. Then we remove irrelevant or unnecessary columns and handle missing values. The next step is data visualization. Here we create visualizations like graph and charts to understand trends, patterns, and also the distribution of the data. This helps in identifying potential relationships between features and target variables. The next step is label encoding. Since machine learning models typically require numerical input, we convert categorical strings like attack or normal into numerical values as 1 or 0. Then the next step is feature extraction. Here we select the relevant features x as x and target variable as y from the dataset, which will be used for model training. Then the next part is feature selection. Here we identify and select the most important features that will contribute to accurate model predictions, removing unnecessary ones that might cause the noise. Then splitting the data into train and validation. The dataset is divided into training and validation subsets, where the training set is used to build the model and validation set is used to evaluate its performance. Coming to building the model. Here we choose machine learning models and build them using the training data. Then the next step is training and building the model. The chosen model is trained with the training data to learn patterns and make the predictions. Then we evaluate them using accuracy, precision, recall, and FN score, and we compare them through graphs. Coming to the part of front end, here we built a simple front end using Flask, which allows users to interact with the system. The registration and login functionality is set up with SQLite as the database. In the next step, the users they input feature values into the front end for prediction purpose. Then that input data is pre-processed, which includes formatting and scaling to match the model's requirements. Then that data will be fed to the train model to make predictions on whether the given data represents attack or not. The last step is final outcome is displayed to front end. So here the prediction result that may be attack or normal is displayed to the user on the front end interface, providing them with the input in a readable format. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used to classify the attacks. And here to implement this project, we need basic requirements, which are nothing but hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview of the project. Now let's execute. To execute, we need to open the code folder of the project, which contains source code files. So let's open. These are the source code files of the project. Let us understand them. Here in the data folder, we have the dataset used in this project. These are the three different types of things. So here we have the dataset. So these are the total different datasets that we have used in this project. Here in the attack light benign, this is the attack light benign type. And here this is the attacks. So these are total different. The data is stored in the different files. So it is stored in total different files. These files will be combined, trained. After pre-processing, we will be training them. So after pre-processing, here is the data set that we have stored it as processed. Let us open it. After combining all the files, after extracting the important features, after selecting the important features, this is the final data that we will be using for training the models for detecting attack. So here we have two classes. One is benign and attack. Benign means there is no attack, and attack means there is attack. There is some malicious activity being done in the backend. Now let's close it. Coming to the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files. And coming to this templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Coming to app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model file. This contains the algorithm information, and that will be loaded into the project code during runtime of the application. And here we have two notebook files. These are the Jupyter notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is the sample file in which we have test cases that we will be using in the front end to detect the attack. And last file we have is the signup.db file. This file is a database file which is used to store the user information. Now let's execute. So copy the path of the code folder of the address bar from the address bar of the file explorer. So I'm copying it. Now open the Anaconda prompt. Here it is open. Give the command cd followed by the space and now paste the copied path. Click on enter. Here if you observe, current directory is changed to the code folders path. So by giving the command cd, current directory will be changed to the path that we have specified. Now we have to compile app.py file. So give the command python space app.py. Now click on enter. So by giving this command, it will execute Python script and perform runtime check for any syntax errors or logical issues. And after running this app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. Here you can see a sign up link, right? We need to click on that for login. Here we need to enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. And here we are supposed to provide username and the password. Give the username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see some parameters, right? We are supposed to enter all of these parameters to predict the attack. Let us understand what are these parameters. The first one we have is the RR. That is nothing but resource record. It is the type of the data record in the DNS system that provides information about a domain. It can represent different types, different data types like A, CNME, MX, etc. Coming to a frequency. This is the frequency or count of A records in the dataset. A records map a domain name to an IPv4 address. Coming to NS frequency. It is the frequency of NS, that is name server, records in the dataset. NS records specify the authoritative DNS server for a domain. Coming to CNAME frequency, it is the frequency of CNAME, that is nothing but canonical name records in the dataset. So CNAME records alias one domain name to another. Coming to SOA frequency, it is the state of the authority, that is SOA records in the dataset. SOA records contain metadata about the domain like the primary DNS server. Coming to null frequency, it is the frequency of null records which do not have a specific value and they are often used in certain DNS configurations. Coming to PTR frequency, it is the frequency of PTR, that is pointer records in the dataset. PTR records are used for reverse DNS lookups, mapping an IP address to a domain name. Coming to HINFO frequency, it is the host information. So it is the frequency of host information records, which provide information about the host, such as CPU type and operating system. Coming to MX frequency, it is a frequency of mail exchange, that is mail exchange records in the dataset. MX records specify mail servers responsible for achieving, that is receiving email for the domain. Coming to text frequency, it is the frequency of text records in the dataset. TXT records store arbitrary text data, often used for email security, that is SPF records. Coming to 4A frequency, that is frequency of AAAA, that is IPv6 address records in the dataset. It is the IPv6 address records. These records map a domain name to IPv6 address. Coming to SRV frequency, it is the service records. These are the frequency service records in the dataset. This specifies services available for the domain like VoIP or instant messaging. Coming to opt frequency, it is the frequency of option. So it is the option records in the dataset. Opt records are used in DNS extensions like DNSSEC, that is DNS security extensions. Coming to RR count, it is the total number of resource records, that is nothing but RRs in the dataset. This indicates how many DNS records are present for a domain. Coming to RR name entropy, it is the entropy, that is a measure of randomness of the resource record names. It indicates the unpredictability of domain names used in the records. Coming to RR name length, it is the average length of the resource record names. This gives insight into the structure and the complexity of the domain name in the DNS records. Coming to distinct NS, it is the number of distinct name server records present in the dataset. This shows how many different name servers are used for the domain. Coming to A records, it is the number of A records in the dataset. A records are used to map domain to an IPv4 address. Coming to TTL mean, it is the mean average time to live value for the records. TTL indicates how long the DNS record is cached by resolvers before it is refreshed. The last one we have is TTL variance. It is a variance in TTL values across the dataset. This shows how much the TTL values differ from the average, indicating variability in cache expiration times. So this is all about the parameters. Now let's enter them. For that, we have to open the sample file, that is the code folder. So let us open it. Let us enter the parameters. So let's try with the first case where RR value is 0, A frequency is 0, NS frequency is also 0. Up to null frequency, we have all zeros. So let us enter all zeros up to null frequency. And then we have PT frequency, that is 1. And H info value is 0. And here, next we have zeros up to RR count. So let's enter zeros up to RR count. So we have entered zeros up to RR count. And then next we have RR name, that is 3.18663520. And next we have RR name length, that is 26. And next we have distinct NS, that is 0. A records is 0. TTL mean value is 1. TTL variance is 0. Now let's click on predict. And here we have class label as 0. Now let's see what will be predicted. Click on predict. So the given input will be pre-processed at the backend, and then train model will be fed with that given input, and then we will be getting the prediction. So here we got the prediction that there is an attack detected. And here you can see that. So there is an attack detected. So there is attack in it. Now let's try with the third test case. So let's try with this test case. Here RR value is 4, A frequency is 4, NS frequency is 0, and we have zeros up to TXT frequency. So let's enter zeros up to TXT frequency. We have entered. Next we have almost zeros up to opt frequency. So let's enter zeros up to opt frequency. And here we have RR count as 2, RR name as 2.87877698882. And next we have RR name length as 18. Distinct NS is 1. The next value is 0. That is A records is 0. And TTL mean is 125. 0 is the TTL variance. Now let's click on predict. So let's see what will be predicted now. And here we got the prediction that there is no attack detected. It is benign. So there is no attack in the given information. Let's try with this test case. Click on prediction. So here RR value is 0 and we have zeros up to null. So let's enter zeros up to null. And then we have the next PTR value as 2. Next we have zeros up to opt frequency. So let's enter zeros up to opt frequency. I think we have crossed it. So here after opt frequency, we have RR count as also 0, and this is the RR name length. I have copied it. So RR name entropy, I'm entering it here. And then next RR name length is 26. And then we have next 2 zeros, and then we have TTL mean as 1 and 0. And here we have class label as 0. Now click on predict. And now we'll see what will be predicted. So here we got prediction that there is an attack detected. Similarly, if you enter all this test case, it will be detected. I mean, here you will be getting detection. If there is attack, it will detect there is attack. If there is no attack, it will show that benign. Let's check with the graphs. Click on graph. So here we have sample outcome graph. This represents the class distribution of the classes, that is the target variable. Here on x-axis we have the target variable and on y-axis we have count. This red color is the attack count and this blue color is the benign count. And this is the correlation matrix graph. This is the correlation matrix graph. This shows the correlation between the variables. And here we have accuracy comparison graph. So this is the accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are used to train the model for detecting the attack. So these are the algorithms that we have used for training. And here this is the classification. This is the precision score comparison graph. This is the FN score and this is the kappa value. And here we have log loss comparison graph. This is the RMSR comparison graph. This is for the heavy attack notebook file. So similarly, we have it for light attack also. Here we have it for light attack. This is the sample outcome graph. Sorry, this is the RMSE comparison graph. This is the sample outcome graph. This is the sample outcome graph. And this is the correlation comparison graph. And this is the precision score comparison graph. This is the FN score comparison. Sorry, this is the precision score and this is the recall score and this is the FN score, and here we have for kappa score. Now click on sign out. In this widget, by giving required inputs to the system, we will be getting the detection whether there is attack or not in the given information. This is how you can prevent the DNS exfiltration attacks. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.